Okay, so now we load this program, Arduino ESP, from here, examples from here. Yes, and going to tools is set up as Arduino Uno. This is what is set up right now on COM5. Programmer is our ESP, and we have this Arduino ESP. We have to upload it into this board, into that chip, this chip, and that's it. Don't upload it. So this chip is containing this Arduino ESP. Now we have to go to tools, MiniCore atmega, and from here is set up as 328. In this is set up as internal 8 megahertz. Baud is 2.7. Here from retained, this one is enable, is 328P. Bootloader, no bootloader here. Default, COM5, and programmer Arduino as ESP. And let's see it here, as you can see, ESP. And now burn the uploader. We will burn the uploader in this chip, like that. And that's it. It's burned. It's resetted. And now we are open basic blink. We can close that one. And from here, we don't change anything that we have here. We leave it as it is. And we are going into Sketch, upload using programmer. Yes. And the blink program is now here. It's communicating through these wires into that board and is opening. This is actually pin 13. And I'm having a LED, this blue LED on the same pin 13 as here for this Arduino Uno pin 13. But here is another pin, is pin 17, I believe it was, for the chip itself. And now when I'm taking out this jumper here, it will stop transmitting lighting in parallel with that one. This one will stop working. So now I'm taking it out. And this is not working because it's not powered anymore, but I'm having these two other wires. I have a 5 volts power supply here, and I can take it out from there as well. And voila. And it's working independently from that. And this is how you are programming an independent chip. This atmega328, independent from that one. And now you can use it wherever you want. Very, very cool. Very, very cool. And that's it. It's that simple. And as you can see, here is not blinking anymore because this was actually driving that LED because it was on the same line. This line is serial clock, SCK line. That's why they were blinking in parallel. I'm having another LED here on the top, and this is on pin 2 of Arduino board. It's actually on the pin 32, the end pin there. So I can put a program in this chip to blink both of them. Let's see this in action. I have to take this out to unpower it. From what I understood, once the bootloader is complete, after I burned the bootloader on it, I can program this chip through this as a programmer without bootloading it. I'm not sure if I have to put this reset, but I will put it anyway. So now it's driving again, but I will send another program here. And let's see. Whew, I don't have a program that is doing that. Okay, and let's put this, upload using programmer. And hopefully it will work without problems. Let's see. Yes, it worked from the start. So this is my new program when I'm using both of these LEDs because I knew exactly where I put that second LED on what pin. And this is it. So now when I'm taking out everything, if I'm powering it, so now if I'm powering it as a standalone, ta-da! Nice, right? Very nice, very, very cool. Yeah. So now without any bootloader, This is just simple, normal programming at this point. Very, very cool. All right. Hello, everybody. How to program a blank atmega328P chip, and is the exact same chip on the Arduino Uno board and probably other like Pico or Nano boards. Is this chip that you can see it here. I purchased them as blank ICs, and I managed to figure out how to program them independently. Here is what I did. I actually got a lot of help from Arduino forums. This guy Petilic from Arduino team, and this guy is awesome. Thank you very much, by the way. Very, very cool dude. He actually told me about this MiniCore add-on, I believe. Yes, these are the indications. This in the post number 33. Yeah, these are the steps that I followed. So this is the link that he sent me to install this MiniCore thing, and this is the link here. And I actually had to read it a little bit. And here is how I managed to install it, following these directives, and I follow them until this point here. It also is including a manual installation. So open Arduino IDE, open the file preferences menu. So from here, file and preference. You can copy it from here. It says there, copied. So you pretty much paste this link there, and that's it. Open the tools now. Boards manager. Click install. After installation is complete, close the boards manager window. Exactly what I did. There is a manual installation actually, and without the help of all that stuff. So you can download a zip file from this page, which is here, from this page. Download this link, download zip, and follow all these steps that are saying here. And also another way of installing the same thing is from KLI installation. KLI, it means command line interface. So run the following command in a terminal. So here in command, right? So here in this terminal, you add this link that you are seeing here. I'm copying it and pasting it, paste, probably like that, and press enter. Yes, and it's doing this thing. You see, is already installed, and this is actually way more simpler than what I just did here in the just paste that thing, press enter, and it's doing its job, and you have it here. Very, very easy to do it. And I actually love command line interfacing, and it's very good that they have it. It's very awesome. Okay, this is the installation of this plugin, I suppose it is. And what this thing is doing, let me get back to my friend here. What this little add-on is doing, this MiniCore, is helping you not to do a lot of other stuff that is under the hood without it. So it's very, very convenient to use it. So, check this out here. This circuit will cause the atmega328 to be automatically reset during the upload. This is very convenient because otherwise you would need to remember to manually reset the atmega328 chip during each upload, and you would need to get the timing just right since the bootloader only remains activated for a short time. So this is one problem. Another good point is this here. So the reason that the board definitions of the MiniCore boards platform have a bootloader that supports arbitrary clock frequencies, whereas the bootloader of the Arduino Uno board's definition is compiled for use only on a board that has a 16 megahertz crystal. This is the most important thing, I believe, here. So in addition to flashing the appropriate bootloader to the atmega328, this will also set the configuration fuses on the chip according to your selections from those menus. This is the most important thing, I believe. Configuration fuses is exactly like in a PIC microcontroller when you have to make those setting registers. And this is configuration registers. This is configuration fuses or configuration registers. And this is very, very tricky, at least for me, especially on PIC microcontrollers. It's always hard for me to set them right. And this is doing it automatically from this MiniCore plugin. And we are back to original installation thing. Now, actually, I will do all these steps that you are seeing here and show you the way of doing it as I did it. All right, and here is the circuit diagram and the setup that I made. This is how I linked to Arduino port in circuit serial programmer ICSP port. Here, this is how it's looking. This was originally a bit longer, and I had to cut it and to shape it and to change all the wires and to put the correct color wires for each pin for this plug, for this jack. And here is where it is situated on the board itself. There, this is its name, ICSP. And this is the blank chip that I remade this pin out. So if I'm opening the datasheet for this chip, the IC datasheet here, as you can see here in the title, atmega328 from Atmel. If we are scrolling down here, this is the actual chip, this TQFP, not this MILF one that is having a different structure and design. So this is my chip that I'm having here. This is the pinout for it from the datasheet. But I didn't use the one that is on the datasheet. I remade it myself, and I also put the correspondent pins by looking on the descriptions of each pin, and I compare each description of each pin with these descriptions that I'm having here and there. And I couldn't find some of these pins from these descriptions, but I kind of get the others. So this is how I figured it out. Where is pin 2 to put that LED, and on pin 17 for pin 13. This is the correspondent on Arduino Uno, this pinout that is in blue here, is what I'm having on this diagram. So this is how I did it, and I find this little circuit on the internet. This is the original, absolutely the original, and I remade it. Here is the first version, and this is the second version. This is the final version that I actually used. In the first version, if you are looking, I don't have this capacitor here on the reset pin, and I was using this reset pin on the chip on pin 29 directly on this jack reset pin. So in version 2, to actually make it work, and after the correction from the forum on Arduino, they told me to take out this, to omit this reset pin that is on the jack here, and link it directly on pin 10 on Arduino Uno air tray. So this is the reset wire that is going into that port on the Arduino directly. And on the circuit, I'm having a 10 kilo pull up, and also a smoothing capacitor from 1 to 10 microfarads. So I put a 2.2 microfarads actually, what I had in hand. I'm not completely sure if this is absolutely critical here, this capacitor, but it's better to smooth because this is a very long wire. Usually on long wires there are a lot of problems, interferences and stuff like that, and it's very good to have a smoothing capacitor next to the pin of the chip. Is a good rule, and also on the power pins of the chip as well. Capacitor. This is an electrolytic one, and this is a tantalum, probably SMD one that I used, and that's from pin 17 serial clock is actually this wire here. This wire is going, you see here, let's see, like this. You see this wire is going into that jack, this white wire, you see, is going into this jack here, and also is moving like that into this point, and then is going directly on to the pin, and then from this point is this resistor and this LED to the negative pad, and that negative pad is linked to this pin here on the chip. And if you see, here is the negative rail of the chip. Actually, it's an entire rail internally, and I actually measured it with my multimeter, this pin here, pin 21 with pin 3 and pin 5, to be absolutely sure that it is a single rail internally, and it is. So it doesn't matter, you don't have to link every pin to negative rail. It is enough only one pin to link it to negative rail, and the other automatically are linked. What I did here, I actually took this point from here, from this LED, and instead of dragging a long wire on this other side, on this negative pad, I actually took this point and linked it to this pin 21, because internally is linked to the negative pad, like I said. And this is the actual link from this pin to the negative pad there. So the current is flowing like this through this wire internally to this chip, and then it's coming out through this wire and finally on this negative pad that I'm having there. And here is another link to this other LED that is coming to negative pad, and this is the actual negative wire that I was putting my alligator clips when I was testing outside the Arduino, unconnected to Arduino power, pretty much. And this is the positive wire as well, to put an alligator clip more easily to that connection there when I'm plugging out this connector, this jack. It's very hard to see. Let me, yeah, this is a capacitor here between negative rail and positive rail, and this is a resistor, a 10 kilo resistor that is between the positive rail and this reset pin point is on this pad here. It represents the reset pad. You see, this is from the other side. So this resistor is going like that to that, and this wire is going into the reset pin. So that's the all the mambo jumbo that I did here. I also linked this positive pin 18. I'm not completely sure if this is absolutely necessary, but I did it anyway. So I'm having here a wire that is going underneath and is coming through this hole, and instead of linking it to that pad there, but because I'm having too much stuff there, I chose to link it somewhere outside of all that jungle of wires. So that's why I link it there. But it should have been here, you know, for the sake of clarity. I also color-coded green for Miss on Mossy, and serial clock is white, and this reset pin is also white, the wire. and red for positive, black for negative, as well other two wires. This is the final circuit, and this is what I used. This is actually the reset pin that it was going inside here, inside this plug in the first version. Then I took it out from here. You can see this little element that was inside that plug, and I put a single pin inside it, and that pin I connected onto pin 10 of the Arduino, exactly like I'm having it here on this diagram. And to be more specific, exactly like here, you see this white wire is going directly into this. This is pin 9, you see, and it's going like that. You see, this is the perspective how you should see it. And this is pin 10, and this is how the perspective is going like that. It's a bit funky. The angle is funky. So see, here is not having that reset wire that I took it out. And this is how it's looking without that capacitor. That was the last thing to add, that capacitor. I'm not completely sure if it's absolutely essential. Actually, they give me, also on the forum, they give me this circuit diagram, and I was looking on it, and they suggested me to link these pins to positive rail and all these pins to negative rail. But like I said before, these are internally linked already. And I was looking here, and I discovered this one reset pin. They also told me to put this 10 kilo to positive rail, and this is my discovery here to put this capacitor, especially for longer wires. Like if it's not a very long wire, you can omit this capacitor, most probably. And this is a circuit diagram for completely other project, but it's good to see how somebody else linked directly the pins of this chip. So that's what this is about. It's like a reference for me to, like a guide, you know, to see how other work it out. And I took a little bit of inspiration from him, and pretty much that's it. This is the positive rail, negative rail, and between these two rails, this 100 nanofarads, and he actually is putting here 200 nanofarads because they are in parallel here for some reason. It doesn't matter. Usually for every microcontroller, from my knowledge at least, 100 nanofarads is very sufficient for interference, but it depends probably on the medium where it's put to work. Maybe if the medium is having too strong spikes and interferences, probably a larger capacitor is needed. But for my home designs, 100 nanofarads was always the best choice to use, and I always use it like that. And this is pretty much all about the circuit diagram and all the components, the minimum components actually, that you must add to program successfully this blank chip, blank microcontroller, and to add some program to it and to bootload it and everything else. All right. And also another very important detail, as you can probably observe, all this is built on a cardboard that I took it from a chocolate. I cut it to a certain size, and I glued this chip here straight right in the middle, and then I dragged all the wires where I needed, and that's it. This is the physical construction of it. And I actually added metallic pads to link all these wires to them and the rest of the components. And as you can probably observe, these three components, this capacitor, this resistor that you can barely see there, and this other capacitor, are true hole components because I didn't plan them originally when I first made this circuit diagram. I didn't know what to add. So these three components are added way after I finished to construct this cardboard layout and the configuration of it. So these are after I finished the board. You know, they are late added components, pretty much. And this is actually the package of all the chips that I receive. And this is the chip that I took it out from here, you see, and I put it there, and I have 10 of them. Relatively cheap price. Let's see. So here, this line, I catch an offer, a Black Friday offer, as you can read here on this line. I saved $361. The cheapest price was $20, $19.50, $20. And what I paid this price here, $15, almost 16, so about $4 cheaper, $361 I saved. So I took them at an offer, and I was actually hunting this Black Friday offer for a week, and when it finally came in, I jumped. I took it a bit less than usual, and it's very good because those $3.61 I can use them for something else, something more awesome. Yeah, knowing all this stuff, if only I could be able to make money out of all this knowledge and all these capabilities of working with all these chips. But unfortunately, it's capitalism, and this is the reality. This is how everything is working. You cannot do absolutely anything. You cannot make any kind of money, and if you try to do it, you will rapidly get stopped by some very obscure people that will jump from nowhere and they will literally put you down, and you cannot do absolutely anything. It's impossible to make any money from all this stuff. Just as a side note, because I tried and nothing is happening. It's not possible. It's just simply not possible. It's like that. Especially here in Romania. I'm not talking about America or Russia or Germany or China. In China, they are jumping leaps and bounds there. But in Romania, everything must be kept on the ground, financially and psychologically. All right. Thank you very much. I believe this is it. Thank you very much for watching, and yeah. See you next time. From your favorite artist electronics, Mr. Kutov. Bye bye.